you guys hear that. I don't think there's anything interesting going on. You hear sirens coming from all these different directions, but yeah, no problem. I'm glad you guys are tuning in for the research meetings. That reminds me, I need to switch contexts now. I think this button still works. Okay, so we're gonna moving on to building HTML systems. I'm gonna just be blathering a bit while I fix a couple of tooling things. This is what I want, fade. I changed some of my screen transitions. So I should get a room loop here every 10 seconds. Hello, CosmoQuest. Thanks for popping in. I'm just about to launch into my next phase of development. So let me give you an indication of what that's going to be here. Building HTML systems. All right. So we're moving to initial permanences. Let's look at the iPad. So here's where we got to last time. That's weird. So there. So here's where we were last time. This is where we're at with building HTML systems. We've done the potential pools. I don't have the legend up yet, but I'm not too worried about that. And then we're going to be working on this idea of initial permanences soon. So, and that is basically given, I'm actually going to copy this. I'm actually going to copy this so that I can mark it up on a different document. So let me copy. I think I can do this. Create a new doc. Paste. I didn't get that image. Whoa. Whoa, whoa, whoa. Hold on. I'm a big fan of this Notability application. I use it all the time. I'm going to turn the paper to that. Okay, there's one other thing that I wanted to grab, which was this image. I think I can put this. Yeah, so this is going to be here. All right. So now I can mark this up. So the idea being given a selected mini column. So this is all in response to a mini column being selected. We're going to show a heat map that shows its connection permanences, which is its relationship to the input space, right? So each, like we said when we were doing the potential pools issue, every mini column has its own relationship with the input space. Let's take a look at that real quick. Move you out of here. Before I show my screen, let me make sure I'm not. I keep accidentally showing screens I don't really mean to show. So I'm going to take a little bit more caution here. Here we go. All right, so here's the GitHub repository that I'm talking about. And wow, that's interesting. So I didn't expect this to change sizes like that. That's weird. Suddenly it changed sizes. OBS, thank you very much. This is Twitch streamers nightmare. Maybe it's, I don't know why that changed sizes. Anyway. So there's, let's look at the live version that we're working on. It does kind of look like a crossword puzzle. It's just waiting because this is just a on-demand Heroku app. It's not always running. So give it a sec while it starts. So here's where we were last time. We had done the combined spatial, combined encoding. So this takes several semantic encodings and combines them into the same space. You can see this is what it looks like to the layer of neurons to the spatial pooler that's going to extract the semantics from this. And this is the actual different fields. This is all coming from a data stream that's just one scalar value moving through time. That's what we're seeing here. And this is our first little simulation of mini columns in the spatial pooler. These are all mini columns. Each one of these is a mini column, and each one of these has a specific relationship with this input space. So you're seeing the input space here, so you can see it moving through the space because we're going forward in time, like I think we're going like an hour at a time forward, and then the value is changing over time. And each one of these mini columns, and remember, a mini column is an actual biological structure in the cortex, in the mammalian neocortex, that enforces the same receptive field for all of the pyramidal neurons within it. So there's some number of pyramidal neurons within each of these mini columns. You can sort of imagine you're looking down on a structure from the top, and each one of these is like a pillar, and it has a bunch of pyramidal neurons in it. Right, so each one of these, and we'll get into that when we start talking about temporal memory, because that's where we start talking about the interactions of the pyramidal neurons within the mini columns. But for right now, we're just looking at one mini column, and it will only connect to these yellow bits in the space. And so as the input, and this is like sensory input, as sensory input comes in, this mini column is going to only see some of that sensory input, and that's denoted by the check marks, and the white X's are the input that it's always going to miss. And this is dependent on different parameters that we're going to set. So that's what we're going to be doing today, is going onward with this. And well, apparently I still have some things to debug as far as my like iPad size. I'll have to figure that out, because I like doing this, but it's not, it keeps resizing on me. Hey, thank you for the follow. Again, let me put that up top. Okay. Thanks for the follow, Suze. I think that's what I saw there. We're always doing biologically brain-inspired type of neural networks here on the channel. Pretty much in one way or another, that's what we're doing. So come on now, there we go. So we're gonna take that visualization that we had before, and we're gonna add another dimension to it. So for each one of those potential pools, like we showed here, there's also a connection strength. So for this mini column can connect to each one of these. Each one of these right here, it can connect to each one of these yellow squares, which is representing one neuron of some input that's coming in. So there needs to be a synaptic connection strength, some type of weight associated with that. So as a part of today's stream, we're going to introduce that weight, and we're going to do it, and we're going to display it as a color. So it's not just going to be yellow all the time now. We're going to have it like a heat map of the connection permanences. We're going to call these permanences. So in order to do this, we need to have some methodology for establishing the initial values of these permanences. So that's what we're going to talk about today. Because creating that little array and making them colored in a certain way, that's easy. We'll do that in probably half an hour, hopefully. The thing where we have to think about is, how do we create those initial permanences so that a good number of these synapses are actually going to be connected? So we're going to talk about the permanence threshold, which is this line, and then how are we going to like distribute the permanences, this mini column's relationship to its input space? How are we going to distribute those permanences around that line so that learning can take place quickly? I don't know what's going on with like the screen blabbering all over the place. I'll have to debug that later. So that's what we're going to do. But I've been streaming for over an hour now with a research meeting, so I am going to take a break. There we go. I'm going to take a quick break. I'll put it on the room loop while I just, take a bio break, get a drink of water, and probably play a little guitar, because that's what I do when I take breaks. So please hang in there, and we will get to some actual JavaScript coding in D3.js and React.js, but most of it is going to be visualizing these biological structures in the neocortex. So thanks for joining. I will be back momentarily. Okay. I'm gonna take my headphones off. So you guys, I think you guys can still hear me. I'm gonna open up the chat channel in Discord too. All right, so there's a live stream in Discord. I just opened that up. I'm gonna mute myself, but anyone can talk to me. Actually, let me know if I need to mute myself. I'll just leave it at that. I'm gonna set up a few things real quick. Live code link is in chat. Okay. Also going to share server. All right, so I am sharing code and sharing the server. If anybody wants to follow along, there's a link in chat. Really want to hang out with you guys, but you gotta go. That's okay. You can always catch it on YouTube later. I think I lost all my CosmoQuest viewers when I took a break. I'm ready to go. Let's do this. Let's do this. Let's see. I think I can. There we go. And I'm also, I'm gonna take the iPad off here, put on outside. There you go. Okay, so first of all, we need to load this server here. Whoops, I have to be on the right screen. Spatial pooler. Go ahead and get our debugger out. Some of this might be obscured a little bit. Let's make this a little bit bigger. Not that. This. Okay. So we're going to create a new diagram. Pretty much all these, we're just creating new diagrams. I'm not going to try and reuse a whole lot of code right now, just because it's easier to think about. So and from my experience of making a lot of diagrams, it's a real, there's so much custom code with each diagram. So we're going to create a new one, and we're going to call it initial permanences. To do this, first let's just create one that displays connection permanences, and then we'll decide how. And then there's like an additional chart to like decide those permanences. So first we'll do the easy bit, which I think I would say is like this bit. It's called receptive fields here, but let's ignore that. Let's not use that term. Let's just call these initial permanences or just permanences. Given one mini column, we're going to display its permanences. So in order to do this, I know we're going to have to write some code. The code is going to be in, let's pop this down. So just as a quick overview, we are in spatial pooling. And here's our potential pools diagram. So I'm going to make some room for this. Another H3, let's just call this permanences. And we're going to have another diagram. Let's just call it permanences. Permanences. Let's just call it permanences. Why not? And then basically I'm going to send it the same stuff. So it's going to be getting data. Actually, it doesn't need data. We're not going to send it data. We will send it initially. It'll handle all its own stuff, but for right now, it's going to handle its own state. Permanences. I think permanence. Yeah, permanence. I think that's right. Permanent. Okay, I'm gonna make sure that I spelled this right before I create a bunch of classes and stuff. Permanence. Permanent. Okay, A. So I was right. A and A. Okay. Now we're gonna create a new React diagram. I'll call it permanences. Permanences. Is this potential pools diagram, except you want to show permanences instead of potential pools? Yeah, pretty much. Pretty much. So it'll be, but like I said, there's certainly going to be opportunities to share code, but I'm not going into this trying to write the best code. I'm going into this just trying to make a very clear diagram. So let's start with this, what we called potential pools, and change it to permanences. I'm gonna really have trouble with this permanences. Okay, diagram, mini column count, connect. So we want to keep mini column count. The connected percent is the same. We're basically doing the potential pool. What I should probably do here, at some point we're going to have to start keeping spatial pooler state outside of all these diagrams. Right now, I'm keeping the state, like this potential pools diagram is establishing a potential pools data set, but it's not sharing it, like it's doing it inside. So they're not going to be linked right away. If you look into here, let's look at the potential pools. So we're creating these data structures here, and they're not global. They're just, so this is not going to be linked initially to the diagram I'm creating right now. Eventually we will get there, and we're going to pull out these calculations into some type of spatial pooler object or something. But for right now, I'm just want to show the diagrams. I'm focusing on visualizations. So we're gonna start writing simple code that does what it needs to do inside the class. So what does it need to know? First, it needs, we'll use the connected percent as its potential pool. So we'll use that. I'm gonna change this to 85 because that's more like what we typically use. We'll give it the same mini column count, but the pools that it creates are not going to be the same as the potential pools one because they're both going to have their own state, and we'll worry about lifting the state up into some type of spatial pooler object later. Okay. So for right now, as long as I import this, I think we'll get 2 of these basically. Permanences from permanences. And here we go. Cannot read property time if undefined, and permanences. Oh, because I'm not sending it data. Right, so we're not going to display data on this one. That's one thing. This is not dependent on data. So let's get rid of that stuff. Not here, here. Is the music too loud? I would just think the music's too loud. Turn it down a little bit. Okay. Data. So when we update render potential pools, that's not the data I wanted. It's only the function, not the mini columns, but the input space. So I don't need to render the input space. There. And I think maybe if I just take this out, I don't render the input space. Let's see if that fixes it. I still am trying to do this, and this is at 61. So, right. So we're not going to have a data. We're going to do this no matter what. There's no data. Whoops. Whoa. Okay. So we're going to encode mini columns, lengths, let's see. And mini columns, potential pools, overlay. Okay, so encode this. We're still in, we're in spatial pooling. Wait a minute. What did I break here? I broke something. This dot encode. We can't encode because there's no data, so we're not encoding. That's right. So we can get rid of the encode. We can get rid of all the encoders. Get rid of the days. The combined color. Get potential. We are still going to do that. We don't need the encoding. We don't need any of these encoders. Right, because we're just setting up a state. The encoding is sort of like live. It's and this component does not need to be live. So let's get rid of this encode function. And where is it called? Nope, nothing's calling it. Okay, let's see what happens now. Set up potential pools. So I'm getting the length of the pools from the encoder. From the encoding. So if there's anything using encoding, I have to use something else. So the main thing are these rectangles for input space, which I'm just going to get rid of this because we're not doing it. What else? So in the potential pools, we're using it to decide how many bits there are, but that's So I need to, that's something I will have to pass in. Since I'm not giving it data, I have to at least tell it the size of the input space. So let's just do that. And we'll tell it 400, I don't know. Okay, so instead of this, we'll say props dot input space size. I doing this? So, okay, in the overlay, I'm using that to decide how to build the rectangles. Still using it at 48, line 48. I thought I got them all. Nope. Okay, props input space size. Hopefully that works. Okay, so here we go. So we got our permanences, but we're not worrying about the input space. The combined encoding is not updating this space at all. It's a big gap between the, oh, the SVG is 500 by default. I'm not gonna worry about that right now. So now we know, now we have a place that we can create these permanence values. So let's just initially create a bunch of random permanence values. So we set up our potential pools already. And when we do that, we're creating this mini columns array, which has a bunch of indices, basically. So the potential pools, after we do this, let's see what we have here. Actually, let's go right here. Because I'm going to call something and say set up initial connection strengths, something like that, which is going to operate much the same way. Now these connection strengths are going to change as the spatial pooler learns, but we're not going to be simulating that yet until we have to create a spatial pooler for that to work. Okay. So I'm just going to add a debugger here, and what I really want is I want to see the mini columns at this point. I'm going to create a data structure. This mini columns, yeah. So we've got mini columns, and each mini column has a potential pool. So I'm going to create a new data structure based on that potential pool. These are the indices. So I could have essentially another data structure called permanences right alongside a potential pool. It'll have the same length as potential pool, but instead of an index, it will contain a connection value, or a weight essentially. So same thing here, somewhat same thing. I think I can do something similar. The connected percent is not what we're going to be using though. Let's get rid of that, and we can't do this anymore. I'm going to go explicitly, let's say, well, I could do this dot many columns equals this dot many columns dot, hey, it did that for me, map v, and then I could just return first of all the potential pool. Well, no, here's what I'll do. I'll return object assign v, but I'm going to override it with connections permanences. Let's call them permanences. Permanences, not with a capital P. Permanence. No. Permanences. Potential pool permanences. Okay, and now I have to come up with a bunch of random numbers, essentially. So I'll do the same thing. Get permanences. And this is going to be, so I'm actually not sure this is going to work. I'll have to send in the potential pools for this to work, right? V dot potential pool, because I need to go through and for each one of those come up with some, actually all I got to do is because this is basically going to be random. I just need to come up with X number of random numbers between 0 and 1 that's the same size as the potential pool count. So how do I do that? If I have a count, well, the count is going to be v dot potential pool dot length, and I just need random numbers, an array of random numbers of that length between 0 and 1, which should be easy to do. With I'm gonna see this new, so this using something like array size key, something like this, right? I don't know, David, if you're listening to this right now, but this is usually where you would come in and tell me how to do this. But I basically want to call math random X number of times and fill an array with it. So
the keys is hydrating it with like 0, 1, 2, 3, 4, 5. So if you just want to do something a certain amount of times, then all you need is just this part.
Just that, yeah. Just the size, and then I can just say for each, or
yeah,
okay. So that's so I can grab this. I'm gonna do the dot array thing. Where was I? Okay, so that'll be like here, and I'm gonna do this the amount of times in the potential pool. Yeah, the bracket. Yeah, and. So that's going to just fill an array with nothing, right? Undefined. Is that right?
No, they'll probably be null. It'll be
null.
Yeah, they won't be there. So, and no value will be there. But you'll be able to still loop through it.
Okay.
So they'll be instantiated to just null.
So maybe the easiest thing to do is just to say map, and then return math.random, right? Think that'll work?
Yeah.
Yeah, I think that'll work.
Yeah, that'll give you an array of random numbers.
Okay, this isn't the way we're going to do it, but this is the way I'm going to do it right now. Because eventually we're going to create a function that distributes these random values in a less random fashion. But for right now, let's see how this works. Move my debugger a bit here. Okay, permanences. Oh, whoops. Whoa, stop doing that. So the way I'm calling map isn't right. Hold on. I guess I have to actually, yeah, there we go. So this .mini column should now have two things, permanences and potential pools, and they should be the same size. Okay, so that looks like that's what happened. Okay. So now let's plot the permanences, and then we'll worry about actually creating them in a better way, because we could do it randomly, but there's problems with that. So instead of render potential pools, let's call this render permanences. Render permanences. And we are going to, in fact, this is kind of silly. I didn't actually need to do, instead of setting up potential pools and then setting up permanences, I'll refactor this later. This can be simplified, but I'll refactor it later. We could do it all at once. We wouldn't have to do it twice. So for rendering permanences, we're using the PP color for everything. So this is where we're going to introduce a function that is going to, whoops, that's not what I wanted. DI, there you go. And I don't think we're gonna need the I. Okay, so we are giving as data the potential pool. Now we're going to start giving as data permanences. Okay, so now the permanences value is going to decide how we do our color. The way I typically do this, I'm going to steal code from somewhere else because I've written this function a million times. Let's see if I can find it. It's usually utils, random torus. There's one that's like hex code, hex something. I'll find it. Excuse me. I thought it was in like a common place. I used it in input space for sure. Initial perms. I may have just copied it around. Draw histogram. How did, is this the one? Labutils? It should be in here. Random arbitrary mod, random box molar run. There's one called like get hex color, red, green, hex color or something. Just bear with me here. I'm close. I hope. Maybe not. I'm certain I used it. I have to go back and look at this. Building HTML systems. Okay, so I'm pretty sure it's an input space. I should be using it here. Okay, so this is already the initial permanences. So that's what I just looked at. The initial perms. Set up dat GUI, load HTML, get random perms. So I will be coming back and looking at this. This is the function we're going to end up messing with, or creating. This is the histogram. What I want is, where's the draw potential pools? Redraw? Redraw. Get random perms, update displays. Oh, it's in this SDR tool. Okay, sorry. SDR drawing. I keep forgetting where that comes from. That comes from something called Selviz. I'm just.
It's just like a D3 color scale, though, right?
Yeah, pretty much. But like I said, I've done it so many times. I know exactly. It's like this little function. I just have to. Is this the one? Here it is. Green to red. So it's just this. So I've used this a bunch of times, obviously. It'll eventually will go in utilities for right now. I'm gonna put it here. And so then we can send it a percentage, which basically will send it a random number and it'll get us red RGB to hex, so like red to green hex value. So we can use that as a color, and that's what we're gonna do. So get green to red. And when we're rendering the permanences here, this is what we're gonna call. We're gonna say return green to red D. And I think we just need to put a hex, a number sign in front of it. Let's see what happens. Did I take the debugger out? Okay, something happened. Something happened. It's not what I wanted. So let me check here. That's not the right cells. Am I in the right place? Yeah. Render permanences. Render mini columns. Render permanences. Here's the green to red. Okay. So the D value, let's see what this returns. Maybe it. That should work. That should work. Okay, so let me see what happened here. Maybe there's a problem with the data. Let me take a... How many recs do I get when this happens? A bunch of recs. So there's 341 of them. But it doesn't seem like they're all being created. Only a few of them. Let me check and see the SVG. Okay, so there's a bunch of recs. They're all just going to the same place. Oh, okay. I just have the width and height wrong. Right. I do need. All right. So I'm just going to take this permanences off, and this is going to have D dot permanences. No, that's not going to work. Because they're both arrays. I need to build an array that, or a data structure that has a permanence and they can't be in their own individual arrays for this to work. I built the data structure wrong. So what I want is D dot permanence here, and d dot, this would be like the potential pool index, right? I'm just going to call it index. So creating the data, so this data structure is not going to be, I'm going to have to create this differently. So when I'm creating the mini columns in this function up here that I was saying, oh, this could be better. So setting up potential pools and the initial and the connection strings, I should just do at the same time. So let's try and combine these into, these aren't even. Let's try and combine these into one. So instead of doing both of these things, we're going to do just set up initial connection strengths, and we'll do the potential pool jazz at the same time. And I'm going to create I'm going to do this entirely different, I think. I'll do. I'm not going to take a bunch of shortcuts here. We're gonna take for each. So this is going to be for each cell in the output space. We're not just going to map the potential pools. We're going to go through every one. So that means array this dot props dot input space length, right? Yeah, input space length. That's going to give me an array of empty things. I'm going to map. Yeah, this is what I'm going to do. I'm going to map, and this is where we're going to do our thing. And we're going to create an object in here. It's going to have a permanence, and it's going to have it's just going to have a permanence. Yeah, it's just going to have a permanence. And the permanence is going to be, if the permanence is undefined, that means it's not in the potential pool. If it is a number, then it is. Okay, so get potential pool. Let's look at, I want to check this. This was pretty, return the subset of indices. So I'm not going to do it like this anymore. All I'm going to do is call this, if it's, yeah, so let's say const permanence equals undefined. Okay, so we'll start with that. And then if p this dot props dot connected %, then we will say permanence equals math dot random. Did I even use this size? No, I could have just, I don't need this, okay. All right, so the idea being we're replacing this, we're doing this a bit more explicitly. Got this wrong one here. And we're saying set up initial connection string. So we're gonna do our permanence or our potential pool calculation right here, and if there's permanence is undefined, that means it's not part of the potential pool. So let's just make sure this doesn't break anything. It's not going to render right. Okay. Permanence is 121 cells, not a function. So that's a problem. 121.
Yeah, didn't you just get rid of the many columns creation?
I did. Yeah, I did. This isn't a return. This is a this dot many columns equals. How about that? I think. That's what I want. I wanted to restructure it so that it was an array at the top level that contained permanence object. Now I don't even need this permanence object. All it needs to do is return permanence. All I need to do is, yeah, return perm. Okay, so now it's just going to be an array of values, either undefined or a permanence value. I still have the same issue here. One. I don't see anything. Oh well. 119. So we're having a problem treating our cells. So whatever I'm sending in here doesn't exist because there's no.
You changed it to dot index, right?
I did. So. Yeah. That's right. So there's no dot permanence here. Although there's something else wrong. That shouldn't have. There's something else wrong before this. There's something wrong here. Because the cell that we're sending, whatever this Rex object is not. Oh. Oh, right. I'm screwing this up somehow. Let me rethink this for a moment. So this is going to be not for the input space. This is for each. I keep forgetting. There's two loops that I have to do right here. There's the one for each mini column I have to come up with, and essentially I'm doing this for one. This is going to be perms for one mini column. Yeah, for the input space. So I have to do this for each mini column length. So this is going to be this mini columns equals, and I'm going to do the same silly thing here. How did I send this in? Mini column count. Okay, so I have to do this mini column count thing, which is I'm going to do the same thing I did here, basically, except with, and we're going to put that inside of it. This is going to be mini column count. This dot props dot mini column count. Okay. And now we're going to do the whole permanent. We're going to do the permanence thing inside of this. That's our perms, and then we return that. I think. Okay, so now the mini column should be an array of arrays. I cannot read priority permanence. Okay, now we're getting to the part that you knew was going to fail. Down in permanences, so D is going to be a permanence now. And we're going to say, let's say let fill equal off color. And if D is not equal undefined, fill equals this. Okay. And now down here when we're saying index, we're going to use we're just going to use I. Just going to use I. Yeah, just gonna use I. Okay. Let's see. Oh boy. What did I do? Okay. Let's see what happened here. So first of all, it's not in the right place at all. Here's my mini columns and my input space. So my input space is, my mini columns is one rectangle. So obviously I screwed up. I got to change the way I'm rendering the mini columns as well, because now this yeah. The data I'm using here, that's going to contain I selected mini column. Is that going to be right? Yeah, that should be right. I don't know if it is. I'm gonna fix the mini column one first, just because I want to see what's wrong, and I could do that just by copying or commenting this out for a moment. Because yeah, so now all we have here is this one rect, and it fills the whole space. Wow. Okay, so obviously I've got a mini column with like one thing in it, I think, and I think that's the problem. So let's debug and find out, not the overlay. This is probably just something really simple that will be easy to fix, I'm guessing. So let me do that. Okay, so this mini columns is undefined. So that's, maybe I shouldn't render this yet. Let's see if we get to it again. Yeah, we get to it again after mini columns is created. It's still undefined there. So that seems to be the problem. Mini columns is not populating properly. So let's go into that here. We'll stop here. This is obviously what's wrong. Okay, so this stuff, prop stuff, mini column. Let's actually stop here if I can get to it. Mini column count is undefined because I put mini column count. That may be it. Maybe that's it. I hope that's it. Get the debugger out of the way, because that still says undefined. Okay, that worked better. Okay, let's put these back and see what they look like now. All right, there's a console error. Oh, that's a warning. Let me get a hard refresh here. Hey Falco, yeah, we got raided by CosmoQuest a half hour ago or so, but they didn't stick around, most of them. Is anybody still here from CosmoQuest? Hello. I forgot to put this thing, BHTMS, if anybody's wondering what I'm working on. Okay, so we've got potential pools, permanences. I just want to look and see, these are here, input space. This is still one rectangle, and the overlay, oh, the overlay we're not going to use on this one at all. So I can get rid of that. And this I'm not going to call potential pool, I'm going to call permanences. Whoops. Okay. Okay, and then we still have the issue where it's not rendering at all. That should be here. So mini columns, so I'm suspecting that mini columns doesn't have what I think it has in it. So let's see. This dot mini column is just 0. Okay, so this is just something simple and stupid I'm doing somewhere here, because this is the only time that I think I'm setting it. And it should be a map. Mini column count. Let's stop here again. Mini column count. Stop here. Okay, the V is undefined. Yeah, right. It is undefined. Yeah. That's fine. So now we're saying, oh, this dot props that input space doesn't work. Right. So this is just a scoping issue. Excuse me. So I'll pull this out. What was it? Input space length. Input length.
You get the second argument to map is what you want this to be, so you can just pass this as the second argument.
Oh, I can.
And then,
all right, I'll do that. Map. Let's just pass this to this. This one, I need to do the same thing. No, yes, I will. So like 2 thises. All right, let's see what happened. Uh-oh, reload. Let's see. there's our permanences, and it's still one rectangle. Okay. I did not expect that. Let's go back to, this is still coming from here. This mini columns must be one rectangle. I want to see what it looks like right here. Obviously it's just one value. No, it's not. Oh, they're all undefined. Okay, so the problem is not in here, it is here or here. One of those. Return perm. Perm is undefined. This dot props dot connected per is not the same. Connected percent.
Oh,
That's
also, I see something right away. This is a const.
Okay, great. Yeah, I'll fix that. Good point. Okay, connected percent. Okay, let's see where we're at now. Perm is a value. Good. And this is an array of values. Okay. And this should continue to accumulate, hopefully. So mini columns is an array, but that's not right. Something's not right here. This should be a larger array. It's not an array of one thing. This perm should not be an array of one. Input space, this is where I want to be, right? Is this dot props, input space length, input space size. Jeez. Should standardize some of these terms, huh? Okay. One more time with feeling. Come on. Oh, stupid debugger. Here we go. I saw it. Did you see it? There we go. All right, so it's using the same random value for each one. That's weird. So, let's check in here. That's probably just because I screwed it up in the rendering function. So let's look in the, I bet it's in here. I bet it's in the render permanences. I bet it's this. So the value is that, the green to red is 0. So what the next one should be different. The values are different, so is this different? 04FF00. Yeah, they're different. So the fill's different.
Do you have the scale or the domain on the red to green one, or is it just a number from 0 to 1?
Oh, it's 0 to 100. So it's so I just have to multiply it by 100. Good catch. Yeah, that's exactly what it is. So it's just this times 100. I don't know why, but that function doesn't take 0 to 1. There we go. That's what I wanted. All right, cool. So every time I refresh this, it should be like a different random connection string. So this is just random connections strengths. And each one should be different. There we go. So you look at every single one. If I go back and forth, let's make this a little bigger. Not you. Okay. So if I go back and forth between this one and this one, my mouse hover is not perfect. I don't know what's going on. It's not really. I'm trying to verify that they're the same. Yeah, they're the same. Okay, just making sure. So this is establishing initial permanences just completely randomly, which isn't exactly what we want, but it's a step in the right direction. Okay, so here's the thing. Okay, I gotta use the restroom again. I'll be right back. And I'll show you why, how we're going to create the initial connections that's not quite randomly. Okay, not yet, because There's only one men's restroom, and somebody just went into it. So the problem, maybe I should explain this. So you could just leave it like this. You could just leave it like random like this. But it will take longer for the network to start learning patterns. What you would rather have, so we haven't talked about the permanence threshold yet. So that's another thing that we need to add to the mix of this. Just like, did we have another threshold? Yeah, when we talked about potential pool, we just had a connection, like a percent. What percent of those inputs were going to even potentially be connected. And now each one of those is going to have an initial strength. And now and there's going to be some threshold. So before we talk about changing the way we create these permanences, let's talk about displaying which ones will be connected given a threshold. Okay, so we're more on the UI stuff, and this is like this part. These dots here, these blue dots, those are connected synapses. So that's what I'm talking about. We're going to display, and the way I've done this is putting a blue dot over top of these rectangles. So let's do that. But now I'm going to use the restroom because I heard him leave. I'll be right back. Boop. So the overlay that we removed, I can put back. So let's do that. It's going to be, I won't call it overlay this time, I'll call it connections. And we're going to create a new render function, just like we rendered overlay. Let's call this render connections. I don't think we're still calling render overlay anywhere. We are. Wasn't doing anything. So we'll call render connections, and these are going to be circles. Excuse me. I think I can keep a lot of this connections. And our last one was I was doing text. So this is going to be circle, and this isn't Rex. Let's call this Cirques du Soleil. Okay. Is this the same, basically? I want to make sure I got this basically right, because this might be a little bit different. Diagram width, G, columns, math, floor, screw, yeah. Okay, yeah. But we're not doing potential pool. We don't need this. The transform is still valid. And this cells is now, excuse me. We're not doing a font size. We're not doing a font weight. We are going to do a fill, and it's just going to be connection color. I'll throw that up here. Const connection color. Blue for now. Okay, we need CX, CY for circle X, circle Y. We might need to make some small adjustments. And what are we going to send into this? This is going to be this dot mini columns, this dot selected mini column. And that will have our connection strength in there. So the color, let's see. Okay, so instead of connection color, I'm going to add a function here. We're going to say di. I don't know if we're going to need it all. But if we return connection, let's let fill equal none and return fill. So there should be no stroke. We shouldn't see any circles. If I make this black, we should see circles now, I think. Or errors. Potential pool is not defined. Yeah, so that's in the dot text. I'm not doing that anymore. Okay, so the circles don't need any text. All right, what does it look like? No circles. All the way down at the bottom here, there should be connections, and that should have circles. And they're there, but something's wrong with my fill. I need a radius. That's what I need. Okay, so the radius, I think it's just R, is going to be cell width. I think that's it. Yeah, okay, so now we got a bunch of black circles. All right, so I don't want black circles. What I want is none, so that should have no circles, no markup at all. All right, great. They're there, they're just not, they have no fill. So now we have to decide, we're only gonna show the connections if the permanence is above the connection threshold. So now we need to add yet another parameter. Connection threshold equals, let's put 0.5. That way, roughly 50% of the randomly chosen permanences will be connected out of the potential pool. So less than 50% overall. Okay, so if our D, which is our permanence, is greater than, I'm gonna grab this from here. Connection threshold equals this dot props dot connection threshold. So if it's above connection threshold, then we will say, do this with brackets, fill equals connected, connection color. Cross your fingers. All right, so I'm a little bit too big. Cell width is maybe half of that. The radius is gonna be half the cell width, and I think they're not quite aligned. Yes, so they need to be moved a little bit to be aligned with the rectangles. So for example, I think they're all like just it looks like they're down a little, so they need to be moved up half of the cell width and to the right. looks like. Yeah. So I'm going to fiddle with this a little bit. To the right. Oh, I actually put +2 here. This was for the text. I don't want that anymore. So they're just a little bit off. Let me make this bigger. Yeah, that looks better. Okay, so I should be able to add half the cell width or subtract half the cell width from Y. Let's do that first. Plus cell width. So really what I want to do is plus half the cell width, okay? And then this one, X times the cell width. So that should fix my Y's. And now I got to move my X's, and all I got to do is add cell width, half the cell width. So that should put all my circles completely aligned. All right, great. So the connections, I'm gonna make this radius a little bit smaller. Let's make it, I'm gonna make the circles a little smaller. There we go. That's a little better. So there we go. So the red ones are connected, and we're showing the connections over top of them, and each one of these should be different, right? So there should be no connections on greens. The red ones are the most highly connected. So that's not bad. That's pretty good. The next thing is actually creating, so let's play around with this a little. I like to play around with things when I make them. So let's make this very small. Let's make the connected percent 95, but the connection threshold is very low. So there'll be so like everything's connected. So this is a very highly connected initial thing. It's going to be hard for this to learn because so many mini columns are going to be activated or competing. Like a ton of mini columns are going to have a lot of overlap. So you don't really want that. You want less. You want an initial something much fewer than that. Connections even fewer than this, I would say. Let's do 85, 85. So 85% are on, and of that, only 15% of those are connected because we put our connection threshold way up. So it has to be, the permanence has to be over 85% within that potential pool for there to be a connection. So it's hard to see another aspect of this, which is the distribution of the connections. Because we're doing this randomly, there is no distribution. It's all totally random. So what I'm going to show you next, first of all, let's commit this because it works and it's not awful. So at this point, we're showing the permanences. We're just not creating the initial connections in the right way or in a smart way. We're just doing it in an easy way. So let's start here. Actually, I'll do it from VS Code. Let's see what we've done here. We have created a new permanences script. Okay, let's take out some things I know we're not using. Diagram padding we're using. Get potential pool we're not doing anymore. Although I'm still doing that thing. Mini column, selected mini column still is being used. These mounts are being used. So on update, we're rendering, setting up an initial connection strength on the first update. Rendering the mini columns, rendering the permanences, and rendering the connections over them. This is the setup for the initial strength, which is working. Render mini columns, render permanences, render connections. This is pretty clean, right? Would you agree with me, David? This is pretty clean. I think I'm happy to commit this class unless you have any other.
Yeah, I want to refactor some of it, but I'll wait until you have the methods that.
Yeah, I'm happy, by the way, David, if you want to go through and refactor things while I'm offline or something and set up a PR, I'm fine with that.
Okay.
If you're interested, I mean, everything you're doing is volunteer work. I understand.
Just stuff like this, right? All this right here could be like 2 lines of code.
Oh, sure.
But,
that type of stuff you can do anytime. I have to work it out in my head first.
Yeah.
And honestly, it's good, like, when we start doing the spatial pooler, and we start going through loops like this, I will not want to simplify the code into 2 lines of code. I will want to be explicit, you know, because I want it to resemble pseudocode. But for this, it's fine. It's just a diagram. So, all right. So our spatial pooler, we added our permanence. We changed this. I'm going to change this. Yeah, I'm going to leave it at 85, and we have a permanence section now. The challenging part, once we get this done, I think what we're going to have to do next is start thinking about creating a spatial pooler object so that it can contain this state, so that it can instantiate itself, and then we pass its state somehow into these things. So the state of the spatial pooler will be something global that runs on the page, and these diagrams will update as its state changes, or if its state changes. But we'll worry about that later. This looks good to me for now. So first pass at initial permanences. Permanences. Diagram. All right. And I will go ahead and push that. So you will get to see this. Anybody who's watching should be able to see this go live pretty quick. Within the next 5 minutes or so, you'll see it. Okay, so here's what I'm talking about. This is what I want to recreate now. So we basically created the top bit here. What I want to do now is create this histogram. And then I think it'll be clear why, because when we create this histogram and I show you the connection distribution, it's not going to look like this hill. It's going to be random, you know. So then we're going to talk about creating basically a Gaussian distribution or a normal distribution of connection strengths around some point. And that's going to be our connection threshold, so that we can sort of group all of these permanences near a threshold so that they're primed to either learn or forget right away, so that changes in the data immediately start to kick off learning in the mini columns. So that's sort of the next thing. And as we do it, we'll create the visualization so you can see exactly how changing the connection threshold versus changing the dynamics of the distribution affect this initial state. So that's the next thing. I want to do this histogram. And I think this should be a part of this diagram. And if I look at what I had on the iPad, I'm not exactly sure how I want to set this up, honestly. So I won't worry too much about where things are. Hello, I can't. I'm trying to move this and it won't let me. Okay, here we go. So I'm just going to create the histogram somewhere. I'll worry about like putting it in the right place at a later date, and we'll just put it underneath it or something. I don't know. But this histogram is what I want to do next. Let's see if this worked. No, it's not quite deployed yet. But this looks nice. I'm happy with this. Okay, so let's go look at the old code again, because that's where I had my histogram stuff at. So this should be, I'm hoping I've got a nice isolated function that's called draw histogram. There it is. Because that would be awesome. So let's see if, this should be easy to do, this draw histogram. And we're going to do it all in D3 again. It's only called once. Draw histogram. Okay, so we'll see how brittle this is when we create our draw histogram function. And connections. All right, so we're going to do the histogram here. Why did that? There we go. Okay. So obviously this is all going to break. Draw histogram. All our permanences, that doesn't exist. Actually, I think I can. I'm not sure what data is going to be. A lot of this stuff I'm going to have to change. All right, so we've got a histogram group. So I'll have to go down here and create a histogram group. Oops, it's going to be class name. Histogram. And I'm gonna treat it, sort of grab it like I have been the others, like this. I was using a bit of a different methodology in this one, but this is better. Histogram, so that's our G. I don't need the columns, I don't need that, but I do want to transform it. And what I was calling SVG is now called G. So let me do this. Let me no, this is the group. Okay, so I'm gonna ignore this right now. And this group is this hist group. I'm gonna rename to G and say this there. So now I've got my group. I'm transforming it somewhere. I don't want to transform it right this time. I want to transform it down. So I'm going to go down, and I'm just going to hard code this. 100. I don't know. For now, it's not going to do anything. It'll probably break. Oh, it didn't break, but it's not going to work because I don't have the right data in the right place. So, okay, on enter append G. I don't think I need to do this. Ooh, I don't want to do this. Pretty sure I don't want to do that. What I want to do is draw a bunch of rectangles inside this histogram. I've got a scale, and this requires a width. So for the width, I'll use this dot diagram width. So that's one linear scale. The number of bins x, that's using that scale. Okay, so the data should be the actual permanences, and I think that is all of the permanences, right? No. This will be just for the selected mini column. So let's try and get a data array that matches this. This dot mini columns. This dot selected mini column. And if I remember correctly, I probably have to map this because this contains. What is this? No, this just contains permanences, right? For each, yeah, that just contains permanences. So I think that's it. That might be it. Let's see, data bins. So I'm creating, yeah, so this is where I'm sending the data. So this is going to give me my histogram bins. d.length. What is, oh, that's the function, okay. Height, I don't think I have a height. Let's give it a height. I don't know, 200 for now. We'll fiddle with it later. Max bins is there. So we're gonna treat our rectangles a certain way. I've got some colors hard coded in here. Rex, G select, rect bar, data bins. Let's see what happens here. Ooh, this isn't gonna work. This isn't gonna work yet, but let's see if we can see the histogram bars at least. Let's see if we can at least see the histogram bars. You can't, but why? Let's see. Oh, I'm probably not calling draw histogram. That's why I haven't seen any errors. So in the updates, after the connections, this dot draw histogram. Now we'll probably see an error. Or not. Wow. I'm super surprised there wasn't an error. Permanences, histogram, and it's got a bunch of recs in it. Okay, but the width is not a number, so that's the problem. Width is not a number. This dot diagram width. This dot props dot diagram width. Okay. Yeah. Let's try again. All right, we have a histogram. Okay, so you can immediately see, even though the histogram's not in the right place, that it's randomly distributed. There's a random distribution of connection strengths, right? And this should update as we move across. It's basically random. This is great. Okay, so let's move this around a little bit and put it in the right spot. Okay. I'm making it the entire diagram width. I'm not sure if that's what I want to do. How am I? And the height is, that's definitely the, I guess it is 200 because I've got this really small. Yeah. Yeah, I guess that is 200 pixels because I'm zoomed in so far, but I need to move it down. Let me add my debug class to this. At least so I can see this SVG, so I can move it way down. Let's move it down a couple hundred pixels. Like 300. All right, maybe 200. Well, 200 is perfect because that's the height that I gave it, but maybe a little bit more. 240. Okay. So as long as it's not interfering, and we will end up drawing an axis, excuse me, for this, so that it looks more like this, and we want a marker. We want the marker to be the connection threshold, which I'm not drawing yet, and we want to be able to change the connection threshold. So that change of the connection threshold I'll do at the page level and assume that the page level will have some input that changes it, and then this will respond in kind as the connection threshold changes. As the connection threshold changes, we should not be remapping or recreating any permanences. We should simply just be moving. But I think actually this one does remap the permanences, but on ours we shouldn't. I don't want to. We'll keep the same permanences. We'll just be moving the threshold. As you can see, like the initial conditions are like recreated every time you refresh this. We won't be doing that. That was a bug in the original one. Okay. So let's at this point change. Put a marker where the connection threshold is, because we know there is a connection threshold. And I think this is, one of these is a marker. Is this it? Yeah, this is the connection threshold. So I need something, I need a line. I think I'll put this inside the group. Actually, there's a line with a threshold, and I'm just setting these things. So if I add a line with class threshold, and this connection threshold I can get because it's this dot props dot connection threshold, and this is not this would be in the group. There's a line with a threshold. So let's put that line inside this histogram group. Line, class name, threshold. Okay. I think that will, and then I'm giving an ID called connection threshold, and I'm setting, so I'm using the scale. As you can see, this X scale that I created up here, that's what I use for all the interpolation across that width. So I'm scaling that threshold I'm putting x1 and xy at the same place, and then just going from 0 to 200 here, that's not going to work. But let's see if it works. So there's the connection threshold, and it's not changing. It's 85, I think I put it. So this needs to be certainly on top of this, not inside of it. I could probably, well, I think I can do that by, whoops. This is just an SVG thing. If I want the line on top, I want to, this append, enter append. I'm appending the rex before it or after it. And so I need to do the line first. Or the line, excuse me, the line needs to be last, because everything else goes on top of it. But that's what I'm doing, right? Right. Instead of append, prepend. No. It's something like that. Okay, this is a D3 thing. D3JS, append, prepend. There's something that allows you to do this. Insert. Oh, I can say insert. I can use insert, I think, instead of append. Let's see. Let's see how broken that. No, so it didn't work. I don't think it worked. Because I have to tell it insert and then new element and another single div. Oh, first child. So I have to do div and then first child, I think. Here we go. All right, so as we change, so if I change this, I'll have to change it in code right now because I don't have a. Actually, I'll make it. I'll just add a component to change it real quick. So we're going to add this to our state for spatial pooling, because right now our only state is whether it's combined or not. So I'm going to call this connection threshold, and we'll say 0.5. That's where we initially set up. And then I will also steal from our encoding numbers, because we're going to get one of these number value inputs in our spatial pooler. So toggle button, and we're also going to have a number value now, and I'm going to steal one of these parameters, so we'll have something that we can change it. Here's where some of our React goodness will come in. Okay, so this is going to be connection threshold. It's a number value. Threshold, the low is 0, the high is 1. And it is going to be connection threshold, whoops, connection threshold on update. There won't be an update. We're not going to update it. Oh, no, yeah, this is going to update, sorry, yeah. Threshold number value, set state. Okay, so we have a connection threshold number input component, and I'm going to add that down here by the permanences. Let's put it right here. All right, so, and then the connection threshold is going to be this .state.connection threshold. Let's see if it works. Oh yeah, I need to set the step. Let me set the step for that. Low, high, step equals 0.1. There we go. Let's make it even. That's perfect. That's wonderful. Let's make it smaller. Let's make it. 0.015. Maybe even. I love it. That's perfect. That's perfect. That's exactly what I want. Eventually, I want a slider, or I perhaps will have this. I'd love to be able to just grab it and move it, but for now, this is okay. I'm gonna even make this. I'm gonna make this really finely grained, so you can move it just a little bit. Beautiful. So this is going to make a bigger difference once we change the distribution of the weights, so it's normal instead of just random. But this is good. We've got the marker, we've got the connection threshold. All right, it's a good place to commit again. Commit often. Let's see. What have we changed here? Well, let's look at spatial pooling first. We added a number value. We lifted connection threshold into a page global. We added the number value connection threshold input and made this state. So that's good. Here, drawing a histogram. Dead space, and then the histogram function. I'm not going to mess with this right now. I don't think I'll style it differently the way I want. Okay, so here's the axis. That's one thing we're missing. We might be able to do this real quickly. So in this one, the old example, we've got this. Let's make that. We should certainly have. It's always nice if you've got a chart to have an axis. So let's make the axis before we commit anything. Close permanences. Okay, so this is what did it last time. It was a select all. I need to reformat a lot of this. Okay, so we're selecting an axis, which I don't think I had. So there should be a group called axis. So let me add that. I think that's just like this. Group, class name, axis. I think that's all I need to do. That's what I'm looking for here. We're just going to send it no data. These are just for styling. Okay, so this is the height that I'm going to have to. Oh, it's already there, but I also transformed it, but it'll transform because it's within the transform group. Okay, this might work. No, it didn't work. I'm sure it's super close to working though. So there's the axis, but it did not find it. So that code I was looking for, it didn't find it. Select all g.axis. This g, which is the dot histogram, should have a subgroup called axis. I'm going to debug right here and see if that G selection is actually going to return anything or not. It does. What am I missing here? D3 axis bottom X, X is scale. Enter append. So it should be adding a class called axis-x-x and then translating it down. And it's not. This definitely has a node in it. It's finding the axis. Why am I doing this data enter crap? I shouldn't be. I should just say, I don't need to enter any data. I should just be able to do this. I think I might have been confused when I wrote that axis. Oh, there it goes. That was it. So something silly I was doing with the data entry. I shouldn't have been using data at all. So I think this will work. So it's cut off a little bit because I don't have any padding in place, but it certainly does work. There we go. And it's aligned well. 0.3 is aligned with 0.3. Okay, so there's other things we could do to clean this up, but let's worry about the actual connection strength distribution at this point. I'm gonna commit this now, and then I'm gonna take a lunch break. I'm gonna go grab something to eat, and then I'm gonna come back. So first, let's commit this. Fixed our permanences, our axis. Otherwise, the other stuff I already looked at. So yeah, let's go. All right. Added permanence histogram. Permanence histogram. There we go. Push it out there, and that's weird. This old one's not. It's not updating. This should be deploying automatically, but it's not. I guess sometimes it just takes a long time. It's not a big deal. All right. I'm gonna go grab something to eat, you guys, and I will be back 15 minutes. 15 minutes. I'll be right back. So how's it going, everybody? I'm gonna eat my lunch. Yeah, I saw your refactor, David. That's fine with me. I'll commit it with our next change. Set up initial connection strengths mat. As long as it works, it works for me. See, this part of the code isn't important that you guys totally understand how it works, honestly. It's the spatial pooler part. And when I get to making the spatial pooler, setting up those strengths with this random, I might end up tearing this up, but for now, just leave it. For now, I mean, you can change it, it's fine. There's another, we're gonna look at another function in the old code. We're probably gonna have to change it. Either way, it doesn't matter whether we start from your version or my version, we're gonna have to change it. Because we're gonna be using a normal distribution to create the, it might not be much of a change. It's just that random function, yeah, it's gonna.
Yeah, yeah.
This should work. But I'll get into it after I eat my torta. I like Mexican sandwiches. Yesterday I saw a guy shooting up heroin in the park. Then the cops came. And he ran and took his syringes and ran into a building and must have hid his syringes or something. I saw them. And he came back out and the cop got him, cuffed him, put him in his car and everything. And then eventually let him go, I guess because he didn't find the syringe. As soon as the cop left, the dude goes back in the store, comes back out, and gets high. And you could see the track marks in his arm too. It was sad. And the guy was wearing a hardware store shirt, so he's obviously on his work break from the hardware store, and he's up in the park shooting up heroin.
Did you stream this on Twitch?
No, no, I wasn't streaming. Usually it's pretty nice out there. I don't usually see people shooting up heroin out there. I love Mexican food because they use jalapenos like salt. Like everything's. This ham sandwich has jalapenos in it. Okay. I'm gonna get back at it now. So the distribution that I want to use, it's called a random Bates distribution. And it'll generally give us a essentially normal distribution, but it allows us to specify variables to give it how spread out it is. So that's why I wanted to use it, because it's easy to change it and watch it as it changes, easier than a Gaussian So it's got two things we can change. Excuse me. The distribution, or excuse me, like the spread, I'd call it, like how spread out it is, and then the center. So we're gonna allow both of those to be changed. This is the function that that I used to do it in the last one. And as you can see, I'm getting some of them from so these are the values that I'm gonna get. I could make them page values, which affect how the distribution is applied. The spread and then the center. So I think that's what we're gonna go with. So I'm gonna grab this. I think this is all that we're gonna need. And go see how we can put this in place. Just comment out, put this in there. So we're not going to be able to apply it directly because it's because this is doing them all at once. So I think we have to do these two things. Where we're doing the random here, I think we have to do two things. First let's do the one, because I think if we just had the one independent variable, like if I just put D3 random baits right here, I think it would work. So let's try that first. And then I'll just use, if I do this and my independent variables, put 3, I don't know. I suspect this will work. I'm not sure. Yeah, so it works, but you know, it's not right. These all changed. Oh yeah, because it's returning exactly what? The same thing for everyone. If I look at this one, the spread, okay, so I put 3, which is too low. So maybe I'll put like 20 or 30. Does that change the way it looks? Hopefully. No, so there's something else wrong here. If I call this is obviously always returning the same value, the same distribution when it should be random. And it's probably because I need to do something else. I'm going to, whoops. Let's play around with this. I just want to see it working. I'm gonna call it a few times, and because I forget how it works. It's been a while. Console. Let's see. Whoa, what do I have? A error? Oh, that's not a real error, I guess. Okay. D3 random baits. That actually gave me an error. D3 is not defined. Come on. It is defined. Why can't it be defined? How do I get to D3 then? Let me try and better understand what I was doing here. So in this case, I was creating my permanences by creating a range, that is the length of the pool, and then mapping out, first doing 2 maps, first getting the random baits and then filtering out a bunch of nulls. Filtering out the nulls if the potential pool is 1. If the potential pool, if the random baits value that it turned back was 1, I'm confused about how this was working. Let me look at the random baits function again, because I think I've just forgotten how to use this. Returns a function for generating random numbers. That's my problem. It returns a function for generating random numbers. So this is a function that generates the random numbers. So then I'm getting a random number here, and I'm adding, and I'm moving it to where the center of the distribution should be. So that's what it is, I think. But only if I'm within the potential pool, which I won't have to do. Okay, so that's what I'm thinking. Okay, so this is actually a function. So I'm going to create the function here. Let me undo this. Okay. So const Bates function equals e3 random Bates. Just gonna use 30. We're just gonna hard code 30 for right now. Okay. So I think I can just do Bates function here, call it, and get something that works. So I still have a debugger? No. I think this should do something different than what we were doing. There we go. That's what I want to see. That's what I want to see. So now you can see why you want to have the connection threshold aligned in the right place with your distribution. So all these are going to be slightly different because this is a random distribution. And I don't have a way to move it back and forth, So you might want to have your connection threshold way up here, and then you move that distribution over so that they all start at that place. I don't know. So we're close here. So I need a couple of variables that I can move that I can change from the outside that will affect this distribution. One of them is called independent variables, which is a parameter to the Bates distribution. I'm going to call it spread, and then the other is sort of the offset or the center. So let's do that real quick. I think we can do this. We have a connection threshold. I'm going to call this connection distribution. We had it at 30. I'll just maybe 25, I don't know. And then the other one was distribution center, which we'll put at 0.5, but we'll be able to move it back and forth. So in order to do this, I want to create some number input changers. One will be called connection distribution, capital C. Connection, let's just call it dist. The low is going to be 0. The high, let's put the low as a 1. The high will be 50, I don't know. And the step is 1, which I don't need because that's the default. And this is connection distribution and connection distribution. And where was it? Where were we? Yeah, here we're going to pass it in. Connection threshold, connection distribution. Whoops, is the connection distribution. Okay. Okay. And now I'm going to do this. So if we change the connection distribution, now I've got to get it from the state in the permanences. Okay. So my Bates function, this 30 is going to come from this dot props dot connection distribute. Whoops. Holy cow, that was weird. Weird copy paste problem. Okay. All right, let's see if this works. This dot state cannot read connection property of null. Connection just this is wrong. Set up initial connections. I don't have a state. Right, it's props, not state. Props. Props. Okay. Okay, so when this happens, violation. That's interesting. So one thing I didn't do, so the distribution has, all of the permanences have to be recalculated if we change this value. And I'm not doing that at all. So I'm changing the value, but nothing is, in component did update, I think I need to update. We're calling update, but we're not setting up initial connection strengths. We're only doing that once. So what I really need to do is check to see if that value changed from the previous time. It's off. So if on update, isn't there a way, like here, yeah, previous props. So I'm gonna pass previous props into this. Previous props. And we're gonna say, if mini column length is 0 or if prev props dot, what did I call it? Connection distribution does not equal, maybe there's a better way to do this, but I think this will set up initial connection strengths once again. Yeah, all right, that's what I wanted. So as I change this, let's take
Don't forget yet. I don't know if you can be able to do that because on the hover you call the update and you won't have previous props.
Oh yeah. I won't have previous props. Yeah, that's true.
So are you able to just move that logic into the update? I mean, into the component update?
Yeah, I could
just
do that.
This part?
Yeah, I could do that. That'll work. Okay, so then I won't be given previous props here. This would just be that. If that means that on mount, no, this will work. This will work, right?
Yeah, you might be able to put it.
No, that's fine. That's fine. Now I can do this too, right? I can change. Yeah, there we go. So now you can really see the spread change. That's basically random, and they should all change. Yeah, we go up. That's decreases the spread more and more and more. So now as we, all right, that's good. It's good. That's good. Very good. All right, we're in a pretty good place here. I can't move the distribution yet, but that should be pretty easy to do. I think I'm just going to give it a range from 0 to 1, and that's going to be the center of the distribution. I think that's what I did in the last one here, and that's all I'm doing is adding a distribution center minus half. So that's basically going to be right here. So let's const center equals this dot props dot dist center, and add that here. Let's call it distribution. Distribution center. Oh, are you good? Did you do that? Or did I do that?
I didn't do them.
I guess I already did it. I don't remember doing this, but there it is. Okay, distribution center, distribution. Obviously I did it because it's misspelled. So we've got our center. Now I need to create a small component for it, input component. Connection distribution. Just copy that and call it distribution center. Dist center. Low is 0, high is 1, step is 0.1, 0.05. Let's make it the same as the other one, 0.2. Okay, distribution center. No, I'm gonna make it 0.1, 0.0, no, that's fine. Distribution center, so. Once again, distribution center. Okay, so now I should just be able to put plus center minus a half. Oh, but I also have to update it again. I have to do this. If that or prev props dot distribution center is not equal this dot props dot distribution center. Update. Ooh, what broke? Oh, there we go, that worked. It just took a while because it's doing that full calculation. So there we go, we're moving it. Gonna decrease the spread here. We can change the connection threshold. Okay, I mean, there's some work we can do with these inputs, but we basically got the functionality that I wanted to show. And this is sort of like a tool to help you potentially identify like what connection how you want to initialize your connection thresholds. This diagram. All right, that's good. The mouse overs are working. Everything seems to be working. Yep, and as we move this, it's not recreating any of the distributions, which is good. I didn't really want it to. Let's make this really big and see what it does. Like 1,000. Should still work. Let's turn this off. I got my widths. That's weird. So the distribution's certainly better, but why didn't this? That's strange. So, oh, I changed the diagram width. I meant to change the input space. That's what I want. That. Yeah. So the input space is a lot bigger. The bigger the input space, the more normal the distribution gets. So if I make this 10,000, this is going to be awful to look at, but if it even works, it's probably way too small. So let's make it 5,000. Oh no, it worked. It just takes a really long time when you've got that many SVG components that you're calculating initial permanences for, but it certainly does work. So now you've got a really nice normal distribution here. Obviously, like the more values you get, the more normal the distribution is going to be, or the more normal it will look. So cool. But that's way too many components. Let's go 500. 500 is better. It's much more responsive. So there we have it, folks. This is how you would establish initial permanences. Now, just to clarify, this is not how Nupic does it. I don't totally know how Nupic does it. I didn't go and look. But I did ask one of the engineers that was working on it at the time how to do it, and he said basically just put a normal distribution around a point that you want the connection threshold to be around, which is what we're doing here. So you want those connection strengths, those permanence values close to your connection threshold. That's the whole point. So that's why we're creating essentially a normal distribution around this point in time. And if we want to change the connection threshold, we probably are going to want to also move the distribution so that it's sort of centered around the connection threshold again, because you want to have this initial state where your permanence values are close to the connection threshold, because that way they will start learning right away and get reinforced, or fall apart, fall away from learning close, and then get repurposed in other places. So there's the idea. That's initial permanences. I mean, there's more we could do. I know I'm sort of pushing through these and leaving a lot of work behind. Like, these labels aren't very nice. I don't even have these labeled. But we'll get to that. We'll come back and clean this stuff up and put nice labels on it and surround it with prose and figure. But that's sort of that's the 20% of the project. I'm working on pushing through to the 80%, all the diagrams, and I'm not going to live stream all of the minutia of creating the prose and fixing all the labels and the diagrams, the little bitty tweaky things that I want to do. So this is what I wanted to get done today, so I'm happy. Any feedback from anybody, I'm open to it. Lost sound on Discord. Looks good to me. I don't know. Oh, yeah. I'm seeing yeah, I do seem to have a bit of a bad Discord connection. All right. There you have it. I have do I have I don't think does this still work? Roll credits? I don't know if it does or not. I might have to be on this screen. No, there it comes. Thanks for following Susie, Murph, and Subtitle. I appreciate it. See everybody. Oh, let's go. Anybody have a raid suggestion? I'm happy to raid somebody. Raiding's nice. CosmoQuest gave me a raid earlier. That was nice of them. Here's somebody interesting you guys will like. He's called Oh Bother. He does a bunch of hardware stuff, 3D printing stuff. It's very popular on Twitch. So let's go raid Oh Bother. You'll like him. Raid Oh Bother. Don't forget to use the brain when you get there. Tell him where you came from. And tell him we said hi. All right, let's go raid. We're gonna raid in 5 seconds, something like that. As soon as inception occurs. Oh, look at this. This is interesting. Inception is occurring. All right, bye everybody. I'm hitting the raid button now. I'm gonna wait 5 seconds like Falco always told me to do.
I'm a nerd. Real light! Thank you for raiding! Party at 9! Real light, party at 9. By the bathroom. No! How you guys doing? We just failed another 3D print.